Mr. Wright here, and welcome to this run-through of this Edexcel Maths IGCSE paper from November 20. If you'd like to download a copy of the question paper, then you will find a link in the description. Hit the link, download the paper, and you can have a good go at the paper before watching the run-throughs. This run-through is in two parts, so there are two films. The first film for the first set of questions and the second film for the rest of the paper. And at the end of the second film, you'll find a short film of me letting you know what the grade boundaries were for this set of papers to enable you to work out what your grade would have been had you sat these papers. If you find this film useful, please do hit like, give me some positive feedback. If you've got any questions, do leave them in the comments, and of course I'll respond. And if you are preparing for your Edexcel IGCSE Maths exam, you might do well to subscribe to the channel. Right, good luck with the paper. Question 1. Got the numbers 1 to 14 in this Venn diagram and asked to list the members of set A intersection B. So that's going to be 2, 4, 6, and 12. List the members which are in not B. So these are the ones which are not in B. So I can see that there are 3 which are in A, and then there are some others which are also not in B. So there are those. A number is picked at random from the numbers in the Venn diagram. Find the probability that this number is in set A, okay, but not in set B. So the number of numbers which qualify for being in set A but not set B is 3 of them, and there are 14 numbers in total. And that is question 1. Question 2. Right, toy cars are made for 15 hours each day, and 5 toy cars are made every 12 seconds. For the toy cars made each day, the probability of a toy car being faulty is 2 in 1,000, or 2,000ths. Work out an estimate for the number of faulty toy cars that are made each day. Well, I better find out how many toy cars are made each day. Now, I know that 5 are made in 12 seconds. So I could multiply that by 5 to work out how many are made in a minute, 60 seconds. And then I could multiply that by 60 to work out how many are made in 1 hour. 25 times 60. 1,500 are made in 1 hour. And of course the factory runs for 15 hours, doesn't it? So 15 times 1,500 gives me 22,500. 22,500 are made in 15 hours. Now, of those, a fraction of 0.002 of them are likely to be faulty. So I need to work out 0.002 multiplied by 22,500 to work out how many of those cars are likely to be faulty, which tells me that 45 cars are likely to be faulty each day. And that's question 2 complete. Question 3. On the grid, draw the graph of y equals 7 minus 4x. Well, I'm going to use my knowledge of gradient and intercept. So the gradient, m, will be minus 4, and the intercept is 7. So it's going to go through 7 on the y-axis. And now the gradient is minus 4. So every time I go along 1, I'm going to go down 4. But be careful, because going along 1 on the x-axis is going along 2 squares. So I go along 1, which takes me to here. And then I go along 4. And on the y-axis, the scale is 1 square for 1 unit. 1, 2, 3, 4. Go along 1 and down 1, 2, 3, 4. Go along 1 and down 1, 2, 3, 4. Right, so that is going to be my line. Now, of course, you are going to use a ruler and a pencil, and I am not. So you're going to join this up, these points, with a straight line using a ruler and a pencil. And that is the graph of y equals 7 minus 4x. Question 4, 6 numbers written in order of size. And the numbers have a median of 9 and a mean of 11. Well, wait a minute. If they've got a median of 9, then that means that the middle number is 9. Now, there is no middle number. So that means that halfway between those two numbers must be 9, which means that x must be 8, because then the median would be 9, because 9 is halfway between 8 and 10. Good. Now, the mean is 11, right? But if I know that the mean is 11 and there are 6 numbers, then the total of the numbers must be 11 times 6, 66. And what have I got so far? I've got 4, 7, 8, and 10, which makes 29, which means 66 minus 29 is what's left. 66 minus 29 is 37, and that must be the total of the two y's. So 2y is 37, so each of those y's must be 37 divided by 2, which is 18.5. So my answer is that x is 8 and y is 18.5. Question 5. Write this as an ordinary number. Well, I'm going to divide it by 10 3 times. So my answer is going to be 0.0057. Write this number in standard form. Well, that's going to be 8 multiplied by, well, it's 1 digit short of a million, isn't it? So it's 10 to the 5, or you could just count the places there. Work out that. Right, well, what I'm going to do is I'm going to stick this expression into my calculator using my fraction button and my power button carefully. And when I do that, my calculator tells me that the value of that is 455 with 4 zeros. For the record, of course, that's 4,550,000. Right, now presumably I need to give that answer in standard form, although this time it doesn't say so. But nonetheless, I'll give my answer in standard form because often one needs to. And so in standard form, that would be 4.55 times 10 to the 6. And that is question 5 done. Question 6. A rocket travelled 100 kilometres at an average speed of that many kilometres per hour. Work out how long it took the rocket to travel the 100 kilometres. So we need to work out the time here. And we need to give our answer in seconds, correct to the nearest second. Right, so let's work out the time. Now we know that the time is the distance divided by the speed. And let's not let these numbers put us off. The distance is 100 kilometres and the speed is 28,440 kilometres an hour. So that means that that time is how many hours? Well, if I stick that in my calculator, I get 5 over 1422. So we're dealing with that many hours. Let's times that by 60, because that's how you convert hours into minutes. And if you multiply that by 60, you'll get 50 over 237 minutes on your calculator. And we need to give our answer in seconds. So let's multiply that by 60 again to get the answer in seconds. And if you do that on your calculator, you'll get 1,000 over 79. So that's how many seconds it is. Now, how many seconds is that? Well, if I change that into a decimal, I get the answer 12.658 and so on. And so to the nearest second, my answer is 13 seconds. Question 7. Okay, an equation to solve. Let's multiply out that bracket. On the left-hand side, 5 fours are 20 minus 5x equals 7 minus 3x. This is an equation with x's on both sides. See which side has the least and get rid of them. Left-hand side has the least, it has minus 5x, so I'm going to plus 5x to both sides. That's going to give me 20 equals 7 plus 2x. Minus 7 from both sides gives me 13 equals 2x. Divide both sides by 2 gives me x equals 6.5. Part B, factorise fully. Well, I can take an 8 out. 8, I can take an m squared out, and I can take a g cubed 8 times 2 is 16. I'll need an m, but no more g's. Plus 8 threes are 24. I don't need any more m's, but I do need g squared. Factorise this fully. Well, I'm going to look for two numbers that multiply to minus 48 and add to minus 2. Okay, so that's going to be minus 8 and plus 6. So my factorising is going to be y minus 8, lots of y plus 6. Hence, it says here, so I'm going to need to use a previous answer. Solve the equation y squared minus 2y minus 48 equals 0. Well, that's the same as the expression I've just factorised, and I know I need to factorise it to solve the quadratic equation. So that's going to be y minus 8 multiplied by y plus 6 equals 0. So y will be 8, because that's the value of y that makes the first bracket equal to 0, or minus 6, because that's the value of y that makes the second bracket equal to 0. And that is question 7 complete. Question 8. A 10-sided polygon. Work out the value of x. Well, I could work out the value of y here because I know what all the interior angles of a 10-sided polygon add up to. All the interior angles of a 10-sided polygon add up to 8 times 180. So the total of all of the angles, 8 times 180, is 1,440. And so from that, I could subtract all the angles that I know. So I'm going to, on my calculator, add up all these angles without messing it up, I hope. And once I've got that total, I can subtract it away from 1,140, and that will give me a value for y. So all those interior angles add up to 1,302. So y is equal to 1,440 minus 1,302, which means that y is equal to 138, and x is equal to 360 minus 138, because it's the rest of that revolution. And that gives me an answer of 222 degrees for x. And that's number 8 done. Number 9. Prices are reduced by 20%. A bag costs that many rupees in the sale, so it's already been reduced by 20%. So that's the amount after the reduction of 20%. And I need to know the amount before that reduction. So this is a reverse percentage change, isn't it? If I was going forwards, I'd have multiplied the original amount by 0.8 to work out what it would be after a 20% reduction. So I'm needing to do 1080 divided by 0.8 this time. 1080 divided by 0.8 gives me an answer of 1,350 rupees. Question 10. Find the highest common factor of a and b. Well, a is already written in terms of its prime factors, but b is not. So I'm going to change that to 2 to the power of 4 times 3 to the power of 37. Now, I can see that they both have 2 to the power of 1 as a factor, and they both have 3 to the power of 37 as a factor. So that is the highest common factor of a and b. Right, part B, express the number a times b as a product of prime factors. Right, well, I'm simply going to have a, which is 2 times 3 to the power of 43, multiplied by b, which is 2 to the power of 4, times 3 to the power of 37. So that's going to give me 2 to the power of 5, adding those two indices, and 3 to the power of 80, adding those two indices. And that is question 10 complete. Question 11. I've got a trapezium here and it has one line of symmetry. Now that's going to be important because it tells me that these two lengths here are equal. So let's just work out those two lengths now. I'm going to do 17.6 minus 8.4 and divide that by 2. Tells you that each of those lengths is 4.6. Okay. Now, I know the area of the trapezium and I know the two lengths. So I know that the height of the trapezium, h, is going to be that area divided by the average of the two lengths, 8.4 plus 17.6 over 2. So that tells me that the height is 13.8. Now let's put what we know on the diagram there. We know that that height is 13.8. And now I see I have a right angle triangle A, B, and X, which will enable me to find alpha. So tan alpha is 4.6 over 13.8. So alpha to one decimal place is 18.4. Now, does that answer the question? The size of angle ABC. Well, ABC is alpha plus 90. So it is 108.4 to one decimal place. Question 12, simultaneous equations. Right, I'm going to start by making the coefficients on the x's equal. So I'm going to multiply this top equation by 3, this bottom equation by 7, and then I'm going to subtract the equations. So top equation multiplied by 3 gives me 21x minus 6y equals 102. And the bottom equation multiplied by 7 gives me 21x plus 35y equals minus 21. Now I'm going to subtract the equations to get rid of the x's. So I'm going to write a minus sign between each to remind me I'm subtracting. So x's go minus 6y minus 35y is minus 41y. 102 minus 21 is 102 plus 21, 123. Divide both sides by minus 41, and I get the answer y is minus 3. Okay, let's put that value of y into equation 1 to get x. Equation 1 is 7x minus 2y equals 34, and y is minus 3. So that's 7x minus 2 times minus 3 equals 34. 7x plus 6 equals 34. Subtract 6 from both sides. 7x is 28. Divide both sides by 7, and x is 4. Now let's check that answer using equation 2. So equation 2 tells me that 3x plus 5y is supposed to equal minus 3. Let's put in our value of x and put in our value of y and see if that does equal minus 3. And lo and behold, it does. So I've got the answer correct, and I can write x equals 4 and y equals minus 3.